This video is going to take you through a discovery lesson where we're going to look at these congruence theorems that we have been talking about, side, 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 side angle, side. And then we're also going to look at a couple that people tend to try and use that aren't really theorems. So for this discovery lesson, you should have these sticks, and they're called angle legs. You should have 2 red and a couple of purple, and then 2 yellow and a protractor, and then a green one. So the first thing that I would like for you to do is actually play with them a little bit and see what you can create. Just get used to snapping them together and see if you can make something fun out of the ones that you've got in front of you. You can just pause the video and do that. Also check out how you put the protractor on the angle legs as well. So go ahead and do that. Pause the video. As we're going through this lesson, I want you to pause the video so that you can actually use the angle legs a little bit. I'm going to just put some questions out there that I want you to think about, and when I do, I'd like for you to think about the answer before I move forward. So that's kind of the format that I would like to use here. So the first thing we're going to look at is side, side, side. And I would like for you to take a yellow, red, and purple, yellow, red, and purple, and put together a triangle. So we're going to snap our red and our yellow and our purple together, and then go ahead and do that with another one. So you have 2 triangles, and we see here we're focusing here on side, side, side. So I can see that the side lengths, these 2 side lengths are congruent, these 2 are congruent, and the 2 red ones are also congruent. Would you say that all of the angles are congruent as well inside both triangles? Yes, we would say that all the angles are congruent. So we have all the sides congruent, we have all the angles congruent, and that makes these 2 triangles congruent. So what if I change one side length? So I'd like for you to take a purple or a green and take out a purple and put in a green. Now when I do that, what does that change? Well, it changes the side length for one. Now this isn't the same length as that, but it also changes the angle measurement. So here I see that these 2 angles are no longer, all 3 of them actually, are no longer exactly identical when I changed a side length. So just changing one of the side lengths change the triangle? Yes, it does. So the question is, if 3 sides of one triangle are all congruent, do they have to be congruent? If all 3 sides are congruent, do they have to be congruent? Well, the answer would be yes, because when all 3 sides are the same, all of the angles have to be the same. So that's one way that we can think through side, side, side being a theorem, and that those 2 triangles are going to be congruent. Again, keep pausing as you go through, because I'm going to do some things not while I'm recording so that this video isn't super long. The next thing we're going to look at is side, angle, side. So for side, angle, side, I want you to use the yellow and the red sticks, and you're going to set both of them up. And then we're going to take the protractor that comes with these, and you're going to put the protractor whichever way you have it set up. So we have the protractor on the angle legs. And if I set this up here, and I've got my bottom angle here, and I've got this one here, and I go over and I've got mine set at 40 degrees. So if I have another one, and this is also set at the exact same angle measure, now I have, and I'm going to move this, wait, I switched the angles, didn't I? I'm going to do this so it matches. So now I have a side, an angle, and a side, side, angle, and side, and all of those are congruent. So we are saying that if you just have a side, an angle, and a side that are congruent, then the triangles are always going to be congruent. So I want you to play with the angle legs a little bit and think through, is that a correct statement, and why? So as you thought about it, hopefully you thought through, You know, if I leave the two sides the same, but I change that middle or included angle, what happens to my third side? Well, my third side is going to change, right? So even if I have the two side lengths that are congruent, if my included angles are not congruent, then I don't have congruent triangles, right? This one is longer than this one. So if you have two triangles that have the exact same side, angle, and side, it forces that third side to be the same, and therefore we can say by side, only a side, angle, and side, that two triangles are congruent. The next one is angle, side, angle, the ASA. So here I've got a triangle, and I want to focus on an angle, a side, and an angle. And I'm going to put this on here, but I'm going to want to move it. So this angle, side, and that angle. So if I change one or two of the side lengths, these two, because I'm focusing angle, side, angle. If I change one of these side lengths here, do I change my angle? Yeah, I do. So if I change this one over here, the angle also changes too. But kind of the converse way to look at it is, if I keep these angles the same, do these two side lengths have to stay the same? The answer is yes. If I change the angle at all, my side length is going to change. These would meet up here. But if I keep these two angles the same, then I always keep these two side lengths the same. So in the angle, side, angle, these two angles are going to dictate these two side lengths, and then it's ASA, so the sides here would both be the same. So if two triangles have the same angle, side, angle, then they're always going to be congruent. The next one we're going to look at is angle, angle, side. So if I start with this triangle, I'm going to use this angle, and this side right here. If I change, so we're saying if you have angle, angle, side, the two triangles have the same of those, then they'll be congruent. So if I take this green off and I change the side length here, now I don't have the same angle here anymore. I don't have the same side here or the same angle here. But again, if I think through it conversely, if I do not change these two angles, and I don't change this side length, then this side always has to stay the same. So we would say that angle, angle, side on two triangles that are congruent would make those two triangles congruent. So for all of these, we're thinking through how the angles dictate the side lengths and how the side lengths dictate the angles. So those are the four theorems that are correct, and they do prove congruence. There's another thing that people will commonly use as an answer and feel as a theorem, but it isn't. And that one is SSA. So I'll write that one here, but know that this one doesn't work. It's not a theorem. So if we think about this with our triangle, I have a side, and an angle right here. If I keep the side length the same, and I keep this side length the same, and I always keep that angle the same, does that ensure that the triangle will stay the same? The answer is no, because this side length is all that needs to be the same. That angle, we're not dictating what that angle needs to be. So this side length can be any measure here, and then it changes the triangle. So just having a side, and an angle the same on both triangles doesn't mean that they are congruent. And here's an example. Both of these triangles have a side. This isn't a triangle because it would need to connect up here. But the side length is the same as this one. This side length is the same. Those angles are the same, but they don't make the same triangle. This side would have to be longer to marry it up. Okay. The last one that people commonly try and use is AAA, which would stand for angle, angle, angle. And again, I crossed it out. I don't want you to get it wrong. But if you have two triangles and they have the same angles, will they necessarily be congruent? Well, the answer is no, because we can dilate triangles. We can change, we can shrink them. These all have the same angles but not the same side lengths. Okay, so that's the end of our discovery lesson. You can go ahead and stop the video and work on the next station.